Okay, what we're going to do today is talk about methodology. And so this is a particular piece of Chapter 1 that focuses only on methodology and how psychologists really study human behavior. We'll cover at first descriptive methods, which are methods that are used to describe human behavior without necessarily making causal inferences. And a causal inference is when you can talk about what is driving or causing a particular behavior. You can't make those kinds of inferences with descriptive methods. You have to use an experiment. So these descriptive methods include case studies, observational studies, and surveys. We'll also talk about correlations because they're used so frequently in the social sciences. And then we'll talk about experiments, which are the only designs that you can use where you can talk about cause and effect of human behavior. So we'll go over some basic terminology with experiments and cover just a really basic design. So hopefully by the end of that discussion, you'll have a nice understanding of the overview of the process of experimentation. We'll also briefly discuss placebo effects and why they're a problem in certain kinds of experiments and how we remedy placebo effects with single and double-blind studies. So just take a minute to read the goals for the module. As noted at first, you're supposed to define and differentiate case studies, observational studies, and surveys. You should be able to explain and interpret correlations. You should be aware of limitations of correlations. Should be able to describe and differentiate independent and dependent variables. You should be able to describe placebo effects and the remedies for placebo effects, which are single and double-blind studies. So to begin with research design, let's talk about these descriptive methods. And once again, it's important to understand that they allow you to describe and predict behavior, but you cannot make causal inferences from descriptive designs. In other words, you can't say what's causing behavior. You can just talk about associations, which is very different than talking about causality. The first descriptive method is a case study, and this is the only design with a sample size equal to 1. So you might study, as we talked about earlier, Phineas Gage as a case study in physiological behavior, or I might study one organization as an industrial organizational psychologist to understand why people are so satisfied at the firm. So regardless of the domain or the particular discipline of psychology, you're studying sample size equal to 1. These are not just, kind of casual notes. People who work primarily with case studies are highly trained in observational techniques. They may use tests to help them understand the individual or the organization. They often use historical information from a person or from a firm or whatever unit that they're studying. It's a wonderful way to study individuals or individual firms or individual phenomena because it's rich information. It can be kind of hard to interpret. In other words, if I study one person like Donald Trump to try to understand the traits that are associated with making it to the presidency, it doesn't necessarily mean that it's helped me understand how other presidents have gotten to that position. When we can't really make those kinds of statements, in other words, when we can't use information from one person to aid our understanding of others, that's called limited generalizability, and that is one limitation of case studies. But they can be, as I said, a very, very rich source of information in terms of understanding that single unit. So it's a wonderful starting point. Just as an example, one of the famous case studies in forensic or criminal psychology was that of John Hinkley. And many years ago, John Hinkley tried to assassinate President Reagan and failed at his attempt. But it was such a brazen attempt, and he didn't really seek to flee. And so we tried to understand what's wrong with him, what led him to try to commit this crime. when we take a look at his brain, you'll see that there are widened fissures in the surface of the brain. In other words, where we usually see kind of rolls of tissue, in between those rolls of tissue, the spaces are larger than you would expect. We see that kind of what's called fissuring as a sign of schizophrenia, alcoholism, other problems. And this was something that was actually introduced in his trial as evidence of an abnormal brain. And there's an image of a normal versus abnormal scan, and the abnormal one is really similar to Hinkley's. And it can be kind of hard to interpret. There are two images here, and the one on the right shows a schizophrenic brain with darker areas that shows deeper fissuring at the surface of the cortex or the outer layer of the brain as compared to the normal. And again, it's intriguing, but it can be difficult to interpret. But a good example of a biologically oriented case study. The next type of study that's descriptive is called observational. And once again, this doesn't mean just kind of casual observation. Instead, you observe without interfering or changing the behavior of the participants. In the natural environment, this kind of observational study is called naturalistic observation. In a lab setting, it's named a laboratory observation. It's important to understand that a laboratory is simply any highly controlled environment. So a classroom that's well controlled might serve as a lab. Typically in observational studies, you have many participants, not just one, as you do in a case study. And the specific behaviors of interest are counted or rated or measured. And you may use more than one rater or more than one person to count the behaviors. Helps you kind of objectify the information or make it more empirical. In other words, it makes it easier to verify. So objectivity is always an issue. There is some lack of control relative to some of the experimental designs that we're going to talk about later, because you're not manipulating anything, you're just observing. It's very valuable as a tool. Just as an example of this, a breakthrough that was discovered based on observational techniques was discovered by Jane Goodall. She observed primates using tools, and at the time we thought only humans were capable of using tools, and her careful observations, which were later verified by other observation, proved that we were wrong about that. And so the quote just basically says that she focused her binoculars and looked at a chimpanzee and watched him push a grass stem into a huge ant mound, and he would wait for the ants to cover the grass and then lick it off like a lollipop. So it showed that the chimpanzee was using this blade of grass as a tool. The reason I'm showing you this is some people may think that observational studies sound very unscientific, but they can actually lead to some very important breakthroughs. Surveys you're probably all too familiar with. We get surveyed for everything from our interest in different products to our reactions to classes. And the format is standardized, which just means that people may get similar questions. You may choose to use a non-standardized format and tailor the questions to the particular survey respondents. For instance, if I wanted to compare and contrast the buying behavior of older and younger shoppers, I may have some questions for older shoppers that were different from those of younger shoppers. These can be in an interview, they can be a questionnaire, it could be over the phone, so lots of different formats. And typically in a survey, attitudes, opinions, and experiences are measured. So the domain of a survey, in other words, what you're measuring, is different from that of a test. Other research designs include just correlational studies. And correlations are just kind of denoted or indicated as a lowercase r. So that lowercase r just means correlation. It's a really simple statistical technique, and you can see the discussion in the text. Basically, this correlation is used to see if two variables are related. So all you can say based on the correlation is whether two variables tend to increase together, decrease together, or increase and decrease in kind of different directions, and whether that increase and decrease is systematic or predictable. So once you measure these two variables, like let's say stress and performance, you can correlate the two things, stress and performance, to yield this R. And the R will tell you whether or not stress is related to performance or not. And this number that's yielded, that gives you the association between the two variables, is called a correlation coefficient. The magnitude of the correlation ranges from 0 to 1. 0 means there's no relationship, and 1 means there's a perfect relationship. Even though you can't say that one variable causes the other in correlations, for instance, if we had a correlation of 1 between stress and performance, we could perfectly predict one from the other. We still couldn't say that one causes the other. The direction can be positive or negative. It just tells you about the direction of the relationship. So the sign, negative or positive, just tells you whether the two variables, stress and performance, vary in the same direction or in different directions. So for stress and performance, it would be in reality a negative correlation, since stress would be going up and performance would be going down. Now, if we had measured relaxation and performance, it could be that relaxation is positively related to performance, so that the more relaxed you are, the higher you perform. The sign itself does not tell you anything about the strength of the relationship between the two variables. It just tells you about whether they're moving in the same or opposite directions. And again, you can't make a causal inference from the correlation just because two things are correlated significantly, and just because two things are correlated to the point where you can predict one from the other, it still doesn't mean one's causing the other. And just as an example of what's called an illusory or a spurious fake correlation, I've provided a link below, www.tylervigen.com, and you can go to that link and learn about all kinds of illusory correlations. The strongest research design is the experiment, and it's the only one that allows cause and effect statements. There are two types: laboratory, that's conducted in a highly controlled setting, and field, which is conducted in a more naturalistic setting. Some basic definitions, and I'm going to put the first two up here because they go hand in hand. The independent variable is manipulated by the experimenter, and the dependent variable is simply measured. So let's say that we're going to look at the impact of an anti-anxiety drug like Xanax on a phobia like fear of flying. If one group of subjects gets Xanax and the other group of subjects does not get Xanax, then Xanax, or this pill, is the independent variable. It's what's manipulated. The anxiety that the person feels would serve as a dependent variable. I'm not manipulating it, I'm simply measuring it. As another example, you might look at the effects of Prozac on depression. So Prozac would be our independent variable and depression as the dependent variable. In the simplest design, group 1 would get no Prozac and group 2 would get Prozac. And then depression would be the dependent variable, and you would expect that perhaps Prozac would decrease anxiety. So in this simple design that we have, there are two groups of participants. The group that receives the pill in this instance would be the experimental group. So the people who get some amount of the independent variable is the experimental group. The control group is used for contrast, and they don't receive the independent variable. So they would not get Prozac. This sounds very simple, but there are some complications, especially in this kind of design. Subjects may have expectations about positive impact of pills. And these expectations produce a placebo effect. In other words, if you take an aspirin when you have a headache, you may feel better immediately, but there's no way the aspirin's in your system yet. You've just kind of created a placebo effect. You expect to feel better, so you do. So let's talk about placebo effects and confounding variables for a minute. Placebo effects are when expectations of a participant in a study rather than the real effects lead to positive results. How do we control these? To control for placebo effects, you can use what's called a single-blind study. So you have an experimental group that gets the real drug and a control group that gets a sugar pill, in other words, a fake drug or a placebo. In single-blind studies, only the participants are quote-unquote blind to the conditions. So, if you wanted to investigate the impact of an anti-anxiety drug on performance, one group would get the real or actual drug, that would be an experimental group. The second would get the placebo or sugar pill, that would be the control group. Now, in that design, any difference in performance between the experimental and control group must be due to the actual effect of the drug and not to a placebo effect. Even better than this is a double-blind study. We learned early on that the people handing out the pill might give away which condition the participant is in just by their body language. For instance, if you're giving somebody a fake pill, you might not make eye contact, and people are very sensitive to these cues. So we use a double-blind study. Neither the participant or the person administering it knows which is real and which is fake. So, these expectations can lead researchers to believe that an intervention has positive effects when it's really due to a placebo. Part of the challenge of research design then is controlling placebo effects and other variables called confounding variables that might compromise the truth of the findings. Confounding variables are also called extraneous variables or nuisance variables, and those are variables that you want to control or eliminate in experimental designs. So confounding variables would take in placebo effects, but also extend beyond this. There might be some other variables you want to control that could influence findings. So you can stop this and just enter the term placebo effects in YouTube and watch the video on extraneous and confounding variables and placebo effects. Well, I hope you enjoyed this discussion that we had on methodology, and be sure and review that in your text, particularly the segment on correlations. Next time we'll be moving to a discussion of biology.